Hello and welcome to Intro to C++ Programming. Today I'll be covering basic input and output. If you want me to just skip over the slides, go to the timestamp below, we'll jump straight into the programming. Other than that, we'll just breeze through the slides. Okay, so terminology in pseudocode. Output. So what output is whatever you see on the screen as a result of some given information. And an output stream is the direction of a sequence of bytes flowing opposite from a source and to a destination. On the inverse, input is when you feed information that's going to later be sent to some destination. And an input stream would be the direction of a sequence of bytes that's carrying the data to be used in the program. A variable is just some storage location or a memory address with a unique identifier which contains some information, whether it be known or unknown, at any given point. Well, it's going to have to be known at some point though. During compiling, a compiler is going to replace all variables with the actual memory address that they're linked to. So there exists the possibility that data might be changed whatever is stored. Not really going to be covering that today. That'll be a little later on, probably not too far. And a constant is a variable whose value can't be changed during execution. Naming conventions going to be kind of important. It's going to be a set of rules for best naming variables and other identifiers in the source code, both syntactically and semantically. So those differences, semantics. This is like the how we're going to be naming things aren't technically wrong, but you should keep to some standard. So classes should be nouns with the first letter of every word capitalized. Try to use whole words when possible, and honestly, when you're writing for something professional, don't be afraid to use like really long names. It just helps. Methods should be verbs with the first letter of the first word lowercase. Sometimes people do uppercase, it doesn't really matter. And every word after the first letter is capitalized. Variables should be written the same way as methods, however, usually people write these lowercase then uppercase. And they should be short, meaningful words unless they're temporary, in which case, you could just use like one letter. And constants should all be uppercase, with each word separated by an underscore. Again, these are technically not incorrect if you do something else, but I wouldn't recommend it. Once you get into your own style, sometimes people use like an underscore at the beginning of their variable name if it's, gonna pop up a lot. But we might run into some issues with that for C++. Syntax. This is where, if there is a mistake, you have to fix it. So, numbers and special symbols can't be the first character of a variable in any programming language. And that being said, although it's not really going to be what we're doing in this particular introduction, in Java, while not technically illegal, spaces could be the first character in a variable name, but it's not a smart idea. In C#, however, you cannot use it as a first character. Why am I stuttering? You can't use it as a first character unless it's a private variable, and I don't really see people do that. In C and C++, anything that is with an underscore is going to be reserved for the standard library. Again, you can do it, but you shouldn't, and you're definitely not going to see it in C++. Maybe in other languages it's fine if you do. Declaration specifies the properties of the identifier. It's usually a variable or something along those lines. Definition, on the other hand, is the initial declaration of a variable to be used later on. May not have some data assigned to it at the initial call. So data type is going to be the attribute of the data that tells the compiler how to interpret it. As you saw in the 0 lessons, if you watched them, data type is very important for C++, but for some languages, those are like really high level, and those are a lot easier on people, is not as important. So primitive data types. There is primitive and composite. So here, primitive is a basic data type already built into the language. So some common ones that you'll see is integer, which is whole numbers. It could be positive or negative, but it's whole numbers. And it only allows signed and unsigned. So signed allows negatives, unsigned doesn't. We're not going into really low level stuff, so I'm probably not going to cover it, but if you see these words anywhere online, if you're looking up help for something, just, and now you know. Floating point. So some range of rational numbers that are stored in binary and allow for single precision, which is just the regular float. It'll be 32 bits, and double precision, which is 64 bits. You might see this in one of the challenge problems, but for now, if you're just beginning, it doesn't matter. Characters. Single characters, it could be digit, symbol, or formatting code, or control code. Booleans have only two possibilities, true or false. Composite data types. Pretty much anything that's not a primitive is a composite, but some common ones that you'll see, and of course they're constructed from primitives, are string, which is made of char types, and instead of using a single quotation, you use a double, and it's just to store a sequence of chars. An array, which is a systematic arrangement of similar objects, be covering arrays in their own video. Lists, which is a countable number of ordered values, we'll cover that in its own video. Struct, which is a fixed set of fields and members which are publicly accessible. Struct is something that's older. It's like a C and C++ thing, so you won't see it in, say, Java or C#. And user-defined types, whatever that may be. Yep. Oh crap. Okay, so some pseudocode. So here's a diagram of what I was talking about with that stream. So let's start up our program. Maybe the first thing that we do is an input. But I don't know, what could it be? Maybe like enter your name. So it'll probably be like a string. So my name is blah. That stream, whenever I typed in, I hit enter, is going to go into my program. My program's going to do whatever it's supposed to do. So I don't know, maybe I'm just going to pop my name back out. Nothing special. Whatever I write pops back out in this output stream, and in my destination on my console, I'm going to get a hello blah. So very simple. We can complicate things, but very simple. So some types of inputs and outputs. Like I said, hitting enter on a keyboard. We can have a controller. Maybe we're getting something from a file. Could be something on the network. Or it could just be like another program. Outputs, console, just another file. A network, or another program. Or just the same program. So, in terms of output, just making it as simple as possible. We want to do that include IOStream. That's going to be our header for recognizing input-output. Using the namespace std, so we're using the standard library. We're going to write our main function, and we're just going to do cout, and then we're going to be doing, whatchamacallit, greater than, and what's happening, I'm just going to put this so I have another line, and if I really wanted to, I can put that std : : it's going to be the same thing, and we don't necessarily need that, but I recommend it. So what are we going to get on the screen? I wrote what's happening and a LMAO. That's what we're going to get on the screen. Had I not included that endel, it would have just, this a LMAO would have appeared right next to that G. No space, unless I made one. Input. So I'm going to include that header file. I want to use this library. I write out my main method. I'm going to set up I didn't even set up a string here, I just set up jars. Okay, so I have a name that I can only have up to 20 characters. So what is my name? Instead of doing this, we're going to be doing this for input. So as I like to put it, input is always greater than the output, right? So input needs a variable to hold the value in place. Very important. When you're writing output, you're also going to want to consider spacing, because, like I said earlier, if not, you're going to just have something right next to it, and you don't want that. It just looks bad. So I ask what my name is. As you can see, I put 3 underscores, and I should get a message that pops back, hey, underscore, 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 how you doing? So let's take a look at primitives. This is going to be pretty quick. I can not assign it a value, I can assign it a value, and I could do multiple on the same line. Cleans up the code real nice. And I have a 0 there. And I can do float or double. These are the 2 precisions that you'll see in C++. When I do a float, you want to indicate it with an F at the end of your number. Doubles are also allowed to be decimals, but they don't necessarily need that F. And if I really want to, for any type of variable, I can do math, if math is allowed. I can declare my chars. I have to use the single quotation though. And bools. I can either just leave it, or I can set it as true. Just a quick thing on that. In most languages, an undefined bool is going to be assigned a false value. It's true in C++, except if it's a global variable. If I were you, I would assign it beforehand, because if you're new, you're going to get confused, and it's not fun. So string, this is a composite type now. We can write string, just use stir, and I use double quotations to store my string. So because string is a composite data type, because string is an object, we're going to learn about that later, it can use methods. So I don't really have any parameters to be passed in this particular method called length, and all that length does is it's a method that allows me to check however long my string is. Now, because I didn't write C out, you're not going to see a result, but if I did, it would say, I don't know, how many characters is this? 4, 9, 10, 5, 6, 7, I don't know, like 17? 17, yeah. And an array. I'm going to cover this in like 2 videos from now. So what an array is it needs to be definitively assigned, but that size could be a variable made elsewhere so long as the types are the same. Just a couple side notes for that. Be careful, C++ is not the most forgiving language. So it needs to be declared at some point. You could declare it here. If you don't declare it here, you have to make up some length here. And if the array size is definitive, but the values don't add up to the size, the compiler's supposed to fill in, not in C++, but in most other languages it will. Again, do be warned, you might get some garbage values. If you want to have a fill-in, what I would recommend is either manually fill it in, or just write bracket 0 bracket. Okay, so let's move on to the program. And I just kind of briefly went over this, but I'll be writing a bunch of different things and deleting them and then posting them later onto the GitHub. And just as a quick thing for the GitHub, starting from here on out up until I get to do more complicated things, like using methods and classes, you might see all of the stuff that I write in a thing called a class. This is for my organization only. You can just copy and paste everything into main for your own purposes. So, without further ado, give me 1 moment and I will switch over to Visual Studio. And we're back. So, first thing that I want to do is include my input-output stream. Pretty much going to include this on every language, so get used to it. Using namespace std, and the first thing that I'm going to cover is some very basic input and output. So I actually just want to use string for this. I'm just going to make a quick comment here. Sometimes Visual Studio likes to go back. So include string. Now because string is not within the standard library, we have to include this header. And this will come with any and all string related things. So I'm gonna, write hello and goodbye. I'm gonna save this as some variable, hello. We're defining it. And we want to do an object. We're not going to cover objects until later, but string is available to be an object because we're including a composite type. So, goodbye. I feel like the old Microsoft. Okay, now we're going to do a very basic hello and goodbye. So I'm just going to show you that this affects literally nothing. See out. I'm not using the variable. I'm just going to be using the string, or not even the string, yeah, the text itself. And for formatting, I'm going to recommend that you use endl. Unless you do something that we'll cover later, just use endl. It makes things neater. And let's use the variable hello. This should include the same thing. Oh, and just a quick thing for C++, in order to separate different things in your statements for, say, cout, and you're not really going to necessarily use it, different things for cin, you want to do this sign here. So this is our command. This is whatever we're going to be adding. In this case, it's our variable. I could also add text here, and I'm also going to add an end line. They're all different statements, so you want to put them as separate. Okay, and what's the next thing that I want to do? I'll actually just show the multiple statements thing. Cout, hello, hello, help. Yeah, help, right? I'm going to show you what happens when they're right next to each other. Space that out. I can have more than one statement. And I'm going to endl, windl. Yeah, that's what I do. And last but not least, cout goog. I don't know what goog means. Goodbye. Let's run this, let's see what happens. Hello, 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 hello. I can have more than one statement. Statement, sorry. And goodbye. So let's take a look at whatever just happened here. So hello. This is just our text. And it pushed that variable hello to a new line. Hello, hello. Because I had no space here, the text is right up next to this variable. And I have a little space here, so that way I can have more than one statement in this single cout. And then of course I add a space at the end, and goodbye is just that little variable that we set earlier. That's very basic output. Let's do some math. Not hard math, I promise. So, I know how to delete things properly. Let's set up 3 variables. I'm going to find the sum of something. Int a. A is some variable of the integer type that we've declared here, but I'm going to give it a definition later on. Int b, I'm going to say that it's some integer that I both declared and defined here. I'm going to give it 3, and c. And it's just some integer that I, whatchamacallit, declared, but I'm going to give a definition later, and I'm going to use c to hold the result. So how do we do that? Well, first I want to just make a definition to a. Let's say a is 97. So then what I'm going to do, because I want c to hold the result of a plus b, this is going to be what we're going to be using for our sum. I could change the plus to a minus, or, an asterisk, which means multiply, or a divide. Doesn't really matter. So what I'm going to be doing is cout result is colon. If the tab doesn't work the first time, do it again inside the quotation. I'm very slowly forgetting words. This is bad. C, and I'm gonna do end and L. Okay. Now, some other really great things to know is how to shorthand. It could be done for math. It could be done for anything really, but shorthand is super great. First one that I'm going to teach you is ++. Now, I'm sure you made the connection between C and C++. Well, let me just write up the statement here. Result is result. I don't want to do is, it's too redundant. Result +1. Well, all that the all that the ++ means is +1. So C plus 1. And L. You see the joke? Laugh. I'm just kidding, I didn't make up C. I didn't make this bad joke here. But, I'm not gonna get into the history between C and C++, but, you know, C++ is like the nicer version of C. Thus, the plus 1. Now, this can also be done by C minus minus, but not C divide and not C times times. It just doesn't work. Only for adding and subtracting. Very useful. I could also just write C plus 1, but C++ is just way nicer to write. Okay, and if I wanted to, say, have a compound statement, it's basically the same as saying, let me write it out for you. Result, I'm gonna say times 2. So it would be the same as me saying times 2 if I were to write C equals C times 2. But that's stupid, so we're gonna write it the smart way. Times 2. And L. Shorthand. It's very nice. It may not want me to do this on the same line. Give me one moment. Yeah, it doesn't want me to write this on the line. Okay, that's not a problem. It's gonna be a little bastard like that then. Whatever, right? Result times equal to 2. Now we're gonna put C. Yeah, if it's gonna give you trouble, just make it into its own line, and since you already did the work up here, you're just gonna write C, because it already stored that value. So let's run it, let's see what happens. I should have put another tab there, my bad. Anyway, so let's check the math here. A3, or A97 plus B3. That should be 100. Okay, good. Result is result plus 1. It also does not want to play nice on the same line, my bad. Let me change that. You stupid fuck. Hate you. Okay, let's fix that. Okay, there we go. So, result plus 1 should be 101 because we just changed the C value. And if we were to multiply 101 times 2, we should get 202. That adds up. I'm sorry. I'm really sorry for that one. Okay, let's move on to if we were to just do something like name printing. Oops. So let's set up a string. I'm going to say name. I'm going to be using my name. You know what? No, I'm going to use a better name. Spider-Man. Okay. And int age. Actually, how old was Spider-Man in Into the Spider-Verse? It's probably like 40, right? Yeah. Spider-Man. Okay. So let's combine this. Let's see what happens if we just wanted to show a name and somebody's age. See out. I'm gonna say my name is, and I don't need a colon there. Who says colons in words, right? Oops. Now let's do a space. Getting all semantic here. I don't like it. Name. And I'm, put that space there. Age. And L. Oops. And I just realized I got rid of return. So as you can see, it works fine. I just don't recommend it. Okay, let's run this. My name is Spider-Man, and it's still tabbing. Whoops. My name is Spider-Man, and I'm 40. Poor Spider-Man. I feel so bad for him in Into the Spider-Verse. Okay, well that works. So now that we've got just a basic showcase down, the last thing I want to cover before I get into input is just some formatting. Very simple stuff, and it will be very useful to you. Oops. Okay, so I'm just going to show it through basic C outlines. So, C out. What's happening? And within the quotations is where we're going to want to put these control codes. So, \n, and I can also just put it right next to it and have another \n. So this should give me 2 new lines. And new line, the control code here, we don't need to include endl, but if you're not going to have like text, there's no point in putting a text thing in NL. I'd rather just write endl, but your coding style, it's the exact same thing, it doesn't matter. So to show its functional equivalence, I'm going to do how's it going, and endl, and I could just put a secondary one just to show that it's equal. And if I want to do something, say like a tab, C out, I'm here, actually, tab, I want to do a secondary tab, and now I'm here. And I don't really need to do an end line, but just to be nice. Okay, let's test it. So as you can see, these two are like exactly the same. It doesn't matter which one you use. And tab, there you go. Now you could set the tabs in your preferences. Mine is just standard. Oh, and as I'm sure that you've been seeing, there is legit arguments over this, so I'm going to bring it up. When you get into coding, there's an argument between using tabs or spaces. Now, for some languages, not necessarily C++, but say Python, spacing does matter. So tabbing may or may not be an issue for you. I don't know, I can switch between both. Like in C++, I'm just going to tab, it doesn't really matter. But for Python, I'm probably just going to use space. And there's arguments, you can get into that. I don't care what side you're on, but if you want to read up on that, go right ahead. It's just fun to think about sometimes. Okay, well, after that little side rant, let's get into input. So we're just going to do, I don't know how old you are. Okay, so I gotta stop doing that. Let's set some variable age. Now we're not gonna define what age is, but we are gonna declare it in advance. So usually when you have input, you should probably give some indication of whatever's happening. So C out, Jow, how old are you? Right? Ugh. And if we want to do something pretty much right next to it, or right at the end of this text statement, we can just leave it like this. If not, we can just do endl, but I'm going to leave it as is. It doesn't really matter. Cin is what we're going to be using for input. So Cin, unlike Cout, going to be doing the opposite direction. And obviously it's Cin. And all that we're going to mention is our variable, age. So Cout. So your, how do you pronounce that? So your age. Here's double your age. Should be a stupid caps lock. Age times 2. And I don't feel the need to end it. Okay. Let's see if it yells at us. How old are you? So long as I don't hit the memory limit, it doesn't matter what I type in. So long as I'm typing an int. So 234. Yay, I'm 468 in 234 years. That's wonderful to know. Now, just a quick thing, because there's no error handling, we're not going to cover that for quite some time. If I were to say enter not numbers, it's going to give me 0. Unless I write something that says that you're in the wrong for doing that. And I didn't, so it doesn't matter. Okay, and there's one last thing that I'm going to show you, and it's not that advanced, but it's something special for C++. There are other things kind of similar in other languages, more so older ones, and there's other things where you could play around with string in other languages. But we're going to be doing something called a special string. So this is specifically for input, and it is for strings and strings only. So what I'm going to do, besides delete whatever I just wrote, is I'm going to add something to our include. And it is, if I can spell things correctly, SS stream. So string stream. Okay. And what this is going to do is, as we'll see in a minute, we're going to be playing along with the input. So string, change, string, and what we want to do after this is have some indication of what we're inputting. What's your full name? So we want to grab whatever the full name is. I'll show you why in a minute. Because sometimes when there is something like a space or something like that, we might have a little bit of an issue grabbing the other piece and using it for something. Now, there are other ways to, I'll say, handle that, but if we want to just keep it kind of simple or be interesting about it, this is what we're going to be doing. So, first thing that we want to do is use this getLine method, and instead of writing out sin, we're going to write it out here, and we're going to say change string. Okay, now what is getLine? GetLine is a method within the S stream, or SS stream, yeah, S stream, yeah. And it's a little hard to read here, but what this is saying is that we want an input and we want a string to use. I don't know why this is giving me such hard stuff to read for new people, but yeah. I would get used to, when you start writing out your own programs, if you look something up and you're not 100% sure what it is and you write it in a nicer editor, say like Visual Studio, if you highlight over it, there's some information that you can get, as I'm sure you've been seeing. This might be a little hard to read, but once you get used to it, it's not that bad. Okay, anyway, that's my rant. So, C out. Cool. Change, whoops. Change string. That's your new name, that's your new life. So, what's your favorite 2 words? And I'm not going to do any end lines on this, it doesn't matter. And I forgot a thing up here. Okay, let's do another get line, sin, change string. Now as you notice, this is the same thing as above, and that's because we're changing the string each time. Okay, and let's just have another output. Change string. I think change string is pretty rad. Okay, let's run this. What's your full name? I don't know. Bat? No. Man Bat. I don't like how that's written. What's your favorite 2 words? Gamer moment. Gamer moment. I think gamer moment is pretty rad. Oh, it hurts to wake up. Okay, this is pretty cool. So, I'm gonna try one more thing called string stream. Ugh, bit of a word twister. And I'm just gonna use something called, what you call it, string stream. It's a method within stream. I don't know why I keep backtapping. Anyway, so string stream is pretty useful for converting values, and what it basically does is it treats the strings like they were streams. Yeah, I like how that sounds. So like C out, C in, etc., etc. And it's for like extracting and inserting. So let's say string, I don't know, convert, sting, convert int. Because we're treating it as an object, I can spell, we'll be fine. Convert int. We'll talk about this later, but I'm not getting any errors, and that's because it is a different type, and this is an object. But I'm gonna change this for the time being because that is a can of worms to open at a much later date. Okay, so let's do string stream, and I just want to note, I think I mentioned it before, but this is a C++ thing. Convert int, and because we're treating this like a stream, we're going to be doing, or like an, we'll be treating it more like an input, as you can see by the way that these separators are. Convert int, and I wrote this backwards. Let me change this. I should probably have used better names, paid more attention, but I didn't. So what we're going to be doing is string stream takes a string, so this little object here, and it converts it into an integer. So if I were to say, I don't know, let's make another example. String. I'm just gonna define it, or declare it, not define it. Let's use float for a price. You don't necessarily need to put an F there, but it's good if you do. Int quantity, and I'm gonna set this to 0. So let's do cout whatever the price of an object is, and I'm gonna be doing both of these. So you'll just see them together if that's okay with you. If that is the case, I'm probably gonna endline this. So what I'm gonna be doing is get line cin string and string stream to convert this. So as you can see, it could just be like a regular variable or it could be an object. It doesn't matter, so long as it's a string of some kind. So string, and we want to convert that into our price. And let's do the same for quantity. I don't know why, but I have like the Opuna soundtrack in my head for absolutely no good reason. It's not relevant, it's just in my head, and I really can't get it out. Sin string. And we want to put that into quantity. Total price. Just gonna put that a little further out. And let's multiply price and quantity together. And I'm gonna just put a little end line. Okay. price. Oh, I didn't put a C out on the first one, so we'll just see the second part first. So, my bad. Let's put a price. 79. I don't know what currency it is. Quantity. 9. Total price. 711. Cool. Okay. We can obviously put a currency sign there, but it doesn't matter. So, this could be in any units. It could be really cheap. Could be really expensive. I don't know. So let me fix that first one, but this should be correct. And let me do a C out over here. Convert it. Okay, I'm sorry. Let's see what happens for both of them. Oops. No, I was right. I should have done int. I should endline this. Ta-da! Works. Wow. Expensive. Okay. I think that's all I wanted to show here. Okay, so the 3 challenge questions for lesson 2 are going to be easy, hard, and medium. I don't know why I went in that order. Anyway, so the easy problems, there's 5. So the first one is find the sum of 3 user-defined variables, and they could be of any numerical type. The second is to find the perimeter and area of a triangle with the input being user-defined, again, any numerical type. So just so you guys don't really have to push yourselves too crazy, perimeter is side 1 plus side 2 plus side 3, and for area, assume that the perimeter has already been halved, so area is going to be square root, and that's perimeter times perimeter minus side 1 times perimeter, perimeter minus side 2, and perimeter, perimeter minus side 3. And let's see, that's the next one. Find the average of 3 user-defined numbers, again, could be of any type, and remember the average is the sum of all values divided by the number of all values. Fourth one is going to be input a user-defined phrase and output it in reverse. And the last one for the easies is going to be find the size in bytes of primitive data types. So what I'm going to be looking for are chars, ints, longs, floats, doubles, bools, long longs, long doubles, and shorts. So for this and for all of them, I just want to let you know you can get away with pretty much using whatever we have learned. And some of these you can also just kind of look up. That's kind of what I'm encouraging for them, as I know we don't really go over. Find the size in bytes. I want you to look that up. So, on to the medium problems. Find the upper and lower limits of primitive data types, including signed and unsigned. So, primitive data types include int, char, short, long, and long long. Second is swap 2 user-defined numbers, could be of any numerical type. Third is convert miles to kilometers up to 2 decimal places. So 1 mile equals 1.60934 kilometers. And let's see the next one. Find the third angle of triangle, could be of any numerical type. So what you want to do is you want to set angle 3 equal to 180 minus angle 1 plus angle 2. And last for the medium is find the ASCII or Unicode of any given character. And let's move on to the hard questions. Hard. Find the area of a polygon with equal sides. Could be of any type. That is numerical. Second is replace lowercase letters with of a string with uppercase. And the third is swap the value of 2 user-defined variables without using a third variable. Could be of any numerical type. So again, everything that's done here could be done using just simple input-output. If you are completely new, there might be a couple of tough challenges in the first one, but I encourage you to look it up. And if you're completely new, you're more than welcome to try any of these. And the answers will again be provided in video form and in the GitHub. So, good luck.